So far in this unit, we've been dealing with equations, so meaning that we have an equal sign. But here, we're going to be dealing with not an equation, but something called an inequality. So an inequality looks like a statement that we see when we have an equation, but instead of an equal sign, there's an inequality sign. So sometimes the inequality sign will look like this, meaning 3 plus x is greater than 8, or you could have the sign go the other way, 3 plus x is less than 8, or you could have a less than or equal to. So here it's 3 plus x is less than or equal to 8. So this line under the inequality symbol means or equal to. And you could flip it around as well. Here's 3 plus x is greater than or equal to 8. So basically, we're trying to find a whole set of x's, not just one x, but an entire set of x's, a lot of x's, that could make the statement true. So just looking at this, we would say, okay, if x is 5, then 5 plus 3 is exactly 8. Well, if we have this side equal 8 and this side equal 8, that is either greater than or equal to 8. So 5 is the minimum number that would make this statement true. So we could say that x equals 5 here. How about if x was 6? Well, 3 plus 6 is 9. 9 is greater than or equal to 8. In fact, it's greater than 8. So x could also equal 6. X could equal 7. 7 plus 3 is 10. That's certainly more than 8. X could equal 8. 8 plus 3 is 11. 11 is certainly more than 8. So do you see that it really, x's could be 5 or anything greater than 5. X could be 5.1. 5.1 would work. 5.1 plus 3 is 8.1. 8.1 is greater than or equal to 8. So in order to show that there's these infinite number of x's that could make this statement true, what we're going to do is, instead of saying x equals a specific thing, because you can see that would take a long time to say all the things it could be equal to, we're going to write x is going to be greater than or equal to 5. All right, so then this is not just saying x could be one specific number, but it could be a whole set of numbers. As long as x is greater than or equal to 5, it will make the statement true. So the way that we would solve it algebraically, we did it intuitively here because we could kind of see it, but the way that you solve it algebraically is the same way that you solve all the equations that we've had up to this point. You use your property of equality, do the same thing to one side that you do to the other, isolate x or whatever variable we have. So here we want to isolate x, so we subtract 3 from both sides, and we're left with x is greater than or equal to 5. Now that we have x completely by itself, we stop. And this is what our answer is, which is what we got intuitively, but this is how we get it algebraically. And you can just leave it like that, and you're good, and you can move on. So everything that we've learned about equations and how to solve equations, you use all of that, except now you have this inequality sign. Let's do another one. Let's say that 1/2 x is less than how about 18? So 1/2 x is less than 18. So how would we solve that? Well, right now 1/2 is the coefficient of x. This is 1/2 times x. And remember, we want to get x completely by itself. We want to have it isolated. So what do? We divide both sides by 1/2, because right now 1/2 is being multiplied against x. So the way that you undo multiplication is with division. The way that you undo addition is through subtraction. So these are the inverse operations. So the inverse operation of multiplication is division. So that's why and because of the property of equality, whatever you do to one side of the equation, you have to do the other. So we're going to divide this side by 1/2 as well. Okay? So 1/2 over 1/2, these cancel out. Anything over itself is 1. So we're left with just x is less than 18 divided by 1/2. Okay, so this is where we do our keep, change, flip. That is 18 divided by 1/2. Now, when you're dividing by this fraction, remember the keep, change, flip? So you keep the 18, you change the division sign to a multiplication sign, and you flip the fraction. What is 18 times 2 now? That would be 36. Okay? So if there was an equal sign here, everything that we just did would be the exact same. We would have done the exact same things to everything. And this would be an equal sign, and this would be an equal sign. But since we have x as less than, we keep that less than, and then this is our answer. Meaning, any number that is less than 36 will make this equation true. Okay? So I'm going to give a couple of examples for you to do on your own, and that's basically how you do inequalities. There is one very special case where we will actually be flipping the sign, and that's when we're dealing with dividing by negatives. That's going to be another video, but for right now, let's just go with what we have learned all about equations and apply them to inequalities. Thanks.